In this video, I want to introduce you to the concept of interquartile range. And this sounds kind of complicated, but really it's not, and you'll see that. So here we have a line, and let's pretend that we have a bunch of data points that are plotted along this line. And it doesn't necessarily matter where they are, but let's just pretend that this is kind of a uniform distribution so that the median of the data set, or the middle number, is going to be perfectly in the middle. And we can call this the median, but for this case, since we're talking about quartiles, let's call this quartile 2. And if you're not familiar with this concept, I encourage you to go watch my video over box and whisker plots, which I will link in the top right-hand corner of the screen. And then we know that if we were to divide the bottom half and top half into, or divide the bottom and top half into halves themselves, we would get, and I'll write these in blue, we will get Q1 or quartile 1, and we would get Q3 or quartile 3. And we also know what the word range means, right? It's going to be the difference between the highest and smallest value. So if we wanted to take just the range of this data set, we would take the maximum value right here and subtract from it the lowest value, so that we would get the distance right here between the lowest and highest value. And in a similar way with the interquartile range, what we're going to do is subtract from Q3 Q1, right? So if we were to subtract, this value right here from this value right here, what we would end up getting is this distance right here between Q1 and Q3. So as it turns out, the interquartile range is actually a very important value. You can think of it as finding the range of the middle 50% of the data set, which, as we will see, helps mitigate the effect of outliers, right? Because if we had an outlier over here, let's say this line extended all the way out here, and then this was our maximum value, well, the range would be really big, right? And we would only have one point here, and then the rest of the points here were here. So this wouldn't be a very accurate showing of what our range is. So instead, we would want to find the interquartile range, or the range of the middle 50% of the data set. Alright, now let's practice finding interquartile range given a data set. So let's begin by ordering these from least to greatest, because obviously they are not ordered like so. So I will go ahead and do that. Let's see here. So this will be 2, 4, 6, 8, 10, 12, and 14. Alright, now that I've listed them least from greatest, I guess I can go ahead and mark these out. Now that I've listed these least to greatest, let's see, there are 7 data entries. So the middle value here is going to be 8. So let's go ahead and denote this as our median, and I'll kind of box this off. It's not perfect, but see, here is Q2. And now if we're to divide these into halves, let's see, the quartile 1 would be 4 here. Since there's 3, we can mark out 2, and then it would be 4. So let's go ahead and say that this is Q1. And then it looks like if this is Q2, then the third quartile here is going to be 12. So this is Q3. All right, now that we've found all of our quartiles, we know how to calculate our interquartile range. It's going to be, and I'll write this is going to be Q3 minus Q1. All right, now we know that Q3 is 12 and Q1 is 4. We can go ahead and plug that into this equation. So let's see, 12 minus 4, and that is going to be 8. All right, now that we have calculated our interquartile range, let's visualize it using a box and whisker plot. So let's see, our minimum here is going to be 2, and then our max would be 14. So let's go ahead and plot that. And I'll plot this all in white. So minimum is there, maximum is here. Our quartiles are 4 and 12, or our outer quartiles, I should say. 4 and 12. And then our median in this case is perfectly in the middle, which would be 8. And I will go ahead and connect all of this. And let's see, let's compare the difference between range and interquartile range for this data set. So if we were to just figure out the range, that would be the difference between the minimum and the maximum, which would be 2, 2, and 14. And let's see, that would be 12. So our range here is 12. And then our interquartile range would be right here between 4 and 12, which is 8. All right, now let's look at a little bit more of a different data set, and I'll go ahead and write it here in order. So let's see, this would be 3, 4, 5, 6, 7, 12. I'll write that to a little bit better, 12, and then 50. And you might notice here why finding the interquartile range might be a little bit more important than in the last one, but let's go ahead and do it. So let's see, our median here, we can notice that this is once again 7, so we can mark out these 3 and these 3, and then the median would be 6. So let's go ahead and draw out from here Q2. And then we could divide this in half, and then we could see that there are once again 3 on both sides. So this would be 4 would be Q1, and then 12 would be Q3. So this here is Q1, and this here is Q3. Now, if you were to find the range of this data set, well, let's see, the maximum minus the minimum, we could see that the range here is equal to 47. And that's not really an accurate view. I mean, yes, the range is 47, right? We go from 3 to 50, but if you were to see this, you would think, oh, the data must be pretty spread out. But really, most of the data here is actually pretty close together. So let's find the interquartile. Range. And I'll write out this formula once again. It is, sorry, I put Q1 here. I'm going to put Q3. Let's go ahead and fix that. And then the interquartile range, which is commonly written IQR. QR, once again, is equal to Q3 minus Q1 So to calculate this, we would have 12 minus 3, which is equal to 9. So our interquartile range in this case is 9. And this is actually a lot more accurate. See, when we have a higher range, we tend to expect all of the data to be spread out pretty far. But in this data set, it's actually pretty close together, and the interquartile range shows that a lot better than the regular range. Let's work on one more problem. All right, so we are already given a data set here, and this says a basketball team scores the following scores across their season. And here we have a data set that lists their scores per game. And we want to figure out the interquartile range of their points scored per game. And we can see here that the data set is already listed from least to greatest. So all that's left to do is find each of the quartiles and then calculate the interquartile range. So let's go ahead and do that. So let's see how many data entries are there in the set. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle will be 6 way through, and we can mark out 5 from each side, but the median here is going to be 16. So this is Q2. And then from here, we could figure out what the Q1 and Q2 are. See, there are 5 on each side, so this is going to be Q1, and then right here 20 is going to be Q3. And then to figure out the interquartile range, we just have to find essentially this distance right here, which is going to be 20 minus 14. Let's see, 20 minus 14, which is equal to 6. And there we have it. This is the interquartile range, and I guess we could write here 6 is the interquartile range of their points scored per game. And once again, what this really shows us is the spread of the middle 50% of their data, which gives us a more accurate idea of how spread out the data set is. And we are done.